Hi, I'm Jeff, and I'm a senior analytic trainer at SAS. In this video, I'm going to talk about building custom model assessment plots in SAS. Now, this video is actually the third video in a series I've done on graphical tools to assess model performance. Now, specifically, we're talking about assessing model performance on models built on a binary target. If you haven't seen the other videos before, you might want to stop this one and check them out. In fact, we'll put links to those videos in the description down below. I've talked about ROC charts in SAS as well as lift charts in SAS. And I'm going to be using some terminology in this video that I more formally defined in those others, so that's why it's a good idea to check those out if you haven't done so yet. Also, in those other videos, I showed you how to construct those charts by hand with a simple numeric example. We're not going to be doing that here. You'll recognize some of the statistics that we're plotting as statistics we've talked about before, so there's no reason to go back and recalculate those. One final thing before we jump to the computer. This trick that I'm going to show you comes from a class that we offer called Advanced Machine Learning in SAS Viya. What we're actually going to be doing is using the SAS code node in Model Studio to use some custom SAS code to actually construct these plots for us. The plots that we're interested in here are not readily available directly from Model Studio, so we're going to have to construct them on our own. Take a look down below and we'll put a link to that class down there as well. All right, let's go ahead and jump right into the computer. Once again, we're running Model Studio on SAS Viya. We're looking at the Data tab on our project, and just like in my other videos, we're going to pretend that we work for a chain of grocery stores that's interested in predicting whether or not a customer purchases some organics product. So we've got a single binary target, target by, indicating historically whether organic purchases have been made or not by that customer. We're going to try to predict that variable based on demographic information as well as prior purchase habits of our customers. All right, I've done a little bit of an analysis for us. We'll take a look at the pipelines. I've got a single pipeline where I've built a single model, gradient boosting. Gradient boosting is a great kind of model, especially if we don't want to worry about a lot of data preparation. That's why we've got essentially just the model in the current pipeline. Now again, I'm not going to be writing the code from scratch, and in fact, it's covered in more detail in the Advanced Machine Learning class, but I will highlight major components of that code once I bring it in. All right, on the gradient boosting node, I'm going to right-click to add a child node. The SAS code node is found under the miscellaneous group, and let's go ahead and bring that in. There's not a whole lot of properties in the properties panel for the SAS code node. In fact, the main one that we're interested in is to open the code editor. Now, of course, if you're already familiar with writing SAS code, you can write your own code directly into this code editor from the ground up. Model Studio even lets you know of some macro variables that it uses behind the scenes that you can use in your code, and those macro variables are listed on the left-hand column. Let's go ahead and import our code. Additional model assessment, and click open. And I'll highlight the main portions of the code. At the very beginning, we're getting the predicted probability variables. That's the probability of an event, as well as the probability of a non-event, and getting the levels of the binary target. Then we use ProcAssess to assess the model performance. And specifically, ProcAssess is giving us some of those statistical measures that we're going to be using to plot on our custom graphs. There's a Data tab that separates the training and validation data sets. And towards the bottom is ProcSGPlot, and that's the part of the code that's actually going to be creating our custom plots for us. You can see that one of the plots is going to be cutoff versus sensitivity. Remember that sensitivity is the true positive rate. We're going to be looking at cutoff versus specificity, where specificity is the true negative rate. Well, we're also looking at cutoff versus the false positive rate, and if you remember, the false positive rate is 1 minus specificity, and that's one of the statistics given on the ROC chart. So this is the scenario where maybe we've interpreted the model on the ROC chart, but we want to look at sensitivity and false positive rates by themselves, separate from each other in two different charts. We're also going to be talking about a plot on accuracy, and we'll talk a little bit more about that statistic once we see the results. All right, I'm going to save the code, close the code editor, and then run the SAS code node. All right, we've got our green check mark. That means the node ran successfully. Let's go ahead and take a look at the results. Now, if you want to see the actual numeric values that are being plotted, the results window is going to contain tables of those values, but they're provided down towards the bottom of the results window. We want to go ahead and take a look at those custom graphs, so we'll start up at the top. Let's start with the sensitivity plot. This is one of the measures on the ROC chart, sensitivity, but here we're plotting it against the cutoff. Remember that to calculate the sensitivity, we rank order the cases based on probability, and then we have cutoffs on that list of ranked probabilities. For each cutoff, everybody above the cutoff is labeled as a 1, everybody below is labeled as a 0. And if you remember from the ROC charts, they're going to typically start with sensitivity equal to 0 and to end up at sensitivity equal to 1. I'm explaining that because we got to be a little bit careful looking at the current plot on sensitivity. The cutoffs are on the horizontal axis, but those cutoffs at the top of the list, the high cutoffs, are on the right-hand side of that horizontal axis. So remember that the ROC chart typically starts at a sensitivity of 0 when the cutoff is 1. That's what we're seeing in the lower right-hand corner. As we go further down that list of sorted cases, we're actually going to the left on the horizontal axis. When we've got the lowest cutoff possible, a cutoff of 0, everybody above that cutoff is labeled as a 1. And remember, that's where we have sensitivity equal to 1. That's what we're getting here on the left-hand side of the plot. So you just got to be a little bit careful about how you're interpreting the cutoff. You're sort of reading it from right to left as you look at that chart. Maybe you want to take a look at specificity. That plot's available also, but remember the ROC chart plots 1 minus specificity, or the false positive rate. Let me maximize that chart. Same sort of scenario. Cutoffs on the horizontal axis. The high cutoffs are on the right-hand edge. That's where sensitivity is 0. And then as we get deeper down that list of sorted customers, we're moving to the left on the horizontal axis. And by the time we're looking at a cutoff of 0, the false positive rate is up to 1, which is exactly what we expect from the ROC chart. Let's talk about one more plot that I didn't talk about in my other videos. One common numeric measure to assess models is misclassification rate. Well, the exact opposite of the misclassification rate is the accuracy. Now, misclassification counts the number of wrong decisions made by your model. That's the false positives or the false negatives. Accuracy is the rate of your model making correct decisions that are 1s or 0s. So here we're looking at the true positive and the true negative rate. It's sort of like the scenario where either of those outcomes are equally weighted. So we're looking at the model's ability to make correct decisions, whether they're positive or negative, at the same rate or at the same time. Now again, we've got the cutoffs on the bottom, and one thing that I certainly like to see here is that for almost all cutoffs, especially when we're at the top of the list, accuracy is very high. I want high accuracy. That means my model's doing a good job at correctly predicting the 1s as well as correctly predicting the 0s. So based on this plot, it looks like my gradient boosting model is doing pretty good in terms of accuracy. I hope you had some fun. I hope you learned some things. Give me a thumbs up if you liked the video. Hey, if you haven't subscribed to our channel, go ahead and do it now. I'll see you later.